Hello, welcome to GP Podcast. Today, we're diving into a really strange paradox, one that sits right at the heart of artificial intelligence. It's a mystery that might just explain why some of the most powerful digital minds on the planet are, well, completely blind to the world right in front of them. You see, on one hand, AI models can crunch numbers and process information at a mind-blowing speed. They can solve equations that would take you or me an entire lifetime. They write poetry, they can code, they master games we've played for centuries. But then, on the other hand, they fail at the most ridiculously simple thing. So I tried something recently. I gave a really advanced AI what I thought was an easy job. Just count the pens on this desk. Its answer was interesting, but totally wrong. It just couldn't see and count the objects properly. And look, this isn't just some random bug. It points to a huge fundamental blind spot in how they're designed. They are blind to our physical world. But here's where the paradox gets really wild. At a lab in Stanford, there's a paralyzed man who was cooking a meal. He isn't moving his arms, he's just using his thoughts. An AI reads the signals from his brain and translates them into commands for robotic arms that do the cooking. So an AI can turn thoughts into physical action? But it can't count a few pens. How is that even possible? And that, right there, that's the central question we're tackling today. What is this absolutely crucial piece of the puzzle that AI is missing? What's holding it back from actually understanding our reality? Well, let's find out. Okay, so to really get to the bottom of this, we have to realize that we're talking about two completely different kinds of intelligence. As AI pioneer Andrej Karpathy says, you have to think of biological minds and artificial minds as basically alien species to one another. This quote, it just nails it. You and me, every animal on Earth, we were shaped over millions of years by one thing: survival. We learned from real physical things like pain and hunger and fear. AI models, though, they were built by companies for a totally different reason: to generate text that gets a positive reaction online. Their entire universe has been the internet. So here's the key takeaway. Our brains are made of carbon, AI brains are made of silicon. Our fundamental goal is to survive, their goal is to get a thumbs up. We learn from real-world, gut-level experiences, while they learn by just predicting the next word in a sentence based on, the entire internet. This total disconnect from the physical world, that's the whole problem right there. And this missing piece, it actually has a name: embodiment. It's the simple fact of having a body, of being able to see and touch and move around in the world. And AI has no idea what a wooden box feels like or why a glass shatters when you drop it. It has zero common sense because it's never actually lived. And we're not talking about a small issue here. While AI might be able to help with about 20% of jobs that are purely intellectual, a whopping 80% of the stuff we do requires interacting with the physical world. I mean, just think about it. Manufacturing, farming, being a first responder, building things, cooking, driving, taking care of someone. All of that is completely impossible for an AI that only lives on a server. So what happens when we fix this? What happens when we finally give AI a body? When we give it eyes? The potential here is so huge. The best way to even think about it is to look back at a massive turning point in our own planet's history. Before this moment, life on Earth was pretty simple. It mostly just reacted to the world through touch and basic chemical signals. The planet was, for all intents and purposes, a world of shadows. But then, something incredible happened. The evolution of sight. The very first primitive eyes allowed creatures to see predators coming, to find food from far away, and to explore their environment. This one single upgrade triggered what we call the Cambrian explosion, an unbelievable burst of biological creativity and complexity. Vision, quite literally, built the world we live in today. So just like sight completely remade the biological world, giving AI embodiment could set off a similar explosion in its abilities. But how do you teach a mind without a body about the physical world? You can't just let a billion-dollar robot learn by bumping into walls. The solution is something straight out of science fiction. You build it a simulated world to live in. And this is the whole idea behind what are called large world models, or LWMs. The goal is to let an AI learn the fundamental rules of reality. Physics, cause and effect, how to move around objects by letting it live and experiment inside a perfect digital copy of our world, a matrix for machines. And right now, the absolute sharpest minds in tech are in a flat-out race to build these new worlds. Fei-Fei, the same person behind that experiment with the paralyzed man, is now building huge digital universes for AI. NVIDIA is creating open-source environments so AI can learn physics. And Google's DeepMind, they're basically making a training academy for AI inside of video games. Inside these simulations, when a virtual box falls, it acts exactly like a real one. It bounces, it tumbles, it obeys gravity. By watching this happen millions and millions of times, the AI starts to build an intuition for physics, kind of like how a baby learns by playing with blocks. So we've gone through the problem of AI's blindness, and we've seen the pretty ambitious solutions people are building. All of this leads us to the final, and maybe most important question. What do we actually want to get out of this technology? Well, the most obvious application is self-driving cars. Companies like Tesla and Waymo are already using these world models, feeding them data from millions of miles of real driving to teach cars how to navigate our world. But the next step is even more profound: fully autonomous science labs. Get this. At the University of Toronto, they had these self-driving labs where AI-controlled robots are running experiments at an insane speed. Just recently, one of these labs found a potential new drug for liver cancer in just 30 days. That's a discovery process that would normally take human researchers years, maybe even a decade. That's the power of embodied AI. But we do need to keep our expectations in check here. A fully autonomous robot butler that can clean your house is still a very distant dream. As OpenAI's co-founder Ilya Sutskever points out, the way humans can just pick up new skills intuitively comes from an unbelievable prior, which is a fancy way of saying millions of years of evolution. You can't just code that into a machine overnight. And this really brings us to a much deeper, more philosophical question, doesn't it? Of course, we want machines that can help us cure diseases or discover new materials. Those are powerful, almost alien intelligences that can focus on specific problems. But do we really need or even want to build machines that are just perfect copies of ourselves? What's the end game here? We are standing on the edge of giving our most powerful creations the ability to actually see and interact with our world. It's a leap in technology as big as the dawn of sight itself. The one question we're left with is this: once AI can truly see our world, what will it decide to do with it? If you liked the video, subscribe, leave a like, comment on what you liked most, and share the video.